So what we're going to do is we're going to try and solve some trigonometric equations. Basically, for these trigonometric equations, you're going to try and find an angle that you can put in here to give you 0.6. So we'll start off with the super basic one. So you want to find an angle that you can put into the cosine function that will give you 0.6. This is basically where you want to get in every question, down to this last one. And then, in the end, when you do this, when you get to here, you are going to have to employ the calculator and use the inverse cosine of 0.6 should give you the value for x. And so, if I were to do that in my calculator, I'll just go second inverse. Oops, clear. I'll go inverse cosine of 0.6. Making sure that I'm in degree mode, because this right here says that your x value should be between 0 and 360 as your domain. So the only acceptable solutions will be between 0 and 360. Okay. So it tells me that the x value that I'm looking for is 53.1 degrees. Okay, that's one of the solutions. Now you always have to check for another solution here, as I'll talk about in class. The x, or since we're talking about the cosine function, the second solution that we need is actually symmetrical around the x-axis. And so if this is 53 degrees, and this will also be 53 degrees, but remember that I want my solution to be 0 and 360, so I can't have negative 63 as an answer. And so what I need to do is find this distance right there, and that distance would be 360 minus 53. So if I do that, 360 minus 53, then I'm going to get 306.8 or 306.9. is also x. Okay, so these two solutions are right in there. Let me show you why. Because, well, I'll show you in class, but I'll show you again. Because remember that the cosine function has to do with the radius and the x value. So it's the x value divided by the radius. So there's actually two angles, 53 degrees, that have this radius and this x value. And then there's another one, it's 306.9, that has this radius and this x value. And so you can see, if I kind of take an angle and rotate it up, an angle and that angle both have the same exact radius and x coordinate. So therefore, the cosine of them will be the same. A little bit of tea in the morning here. And I can show you that, actually. It's 53.1 and 306.9. So if I do the cosine of 53.1, I'm going to get 0.6. Oh, I didn't hit cosine. Yeah. Let me retype that in there. Second cosine of 53.1. Oops. Forgot a parenthesis. 0.6. And if I do second cosine of 306.9, 306, oh shoot, 06.9, that is also going to be 0.6. So notice there are two angles within the domain that give me a solution. So that's basically the main focus of today's questions, is when you have one of these trigonometric equations, you're always going to have two answers. Or not always, but most cases you'll have two answers. Alright, so let's do this one. 3 cosecant x plus 2 is equal to 0. Same situation. X, the resulting solutions should be between 0 and 360. So basically what I want to try and do here is isolate x, and so I'll subtract a 2 from both sides. And I will divide by 3 on both sides. Cosecant x is equal to a negative 2/3. Now I'll use an identity to change cosecant x into 1 over sine x. Then I'll reciprocate both sides. Sine of x is equal to a (3 over negative 2). And then I'll do sine inverse, of 3 over negative 2 is equal to x. And now I probably will get two solutions. This one I actually won't get two solutions, but this is basically the algebra that we would go through to get this far. And the problem here is well, we've got a bit of a problem. This is basically what the issue is. I believe we've got a problem. Let me go back here. Divided by 2, or sorry, subtracted 2, divided by 3. Reciprocated it. Yep, this is all correct. And so, in the end, if I now try and type in the sine inverse of negative 3/2, I'm going to get undefined. And so therefore there actually is no angle that I could place in here to make it so that this side is equal to 0. Okay? And that's basically the idea there. Yeah. Okay, so that one is undefined. Why is it undefined? Real quickly. Sine inverse of 3 over negative 2, remember that the largest answer that sine will ever give us is 1. Unless, of course, it's got like transformations on it. For example, if there was another 3 here, then this whole stuff could give us this number, but then you would actually divide by 3 again, and then you would look for when it would give you 1/2. Anyway, that's kind of the idea. So when you go to plug some of these in here, some of them are going to be undefined. Okay, so let's look at another one here. Two tangent of squared theta plus tangent of theta minus 1 is equal to 0. And in this case, theta is either between 0 or 2 pi, or 0 and 360. Same thing, but now I'm going to work in radians rather than degrees. I'll have to remember to change my calculator over to radians. And so, how do I solve this guy over here? There's a couple of ways of doing it. We can realize that this is factorable using the x method of factoring. I've got 2 here, things that I can multiply tangent and 2 tangent to get 2 tangent squared. And I could multiply together a -1 and a +1 to get a -1. Remember, I'm now doing the x method for factoring. 2 tangent times 1 is 2 tangent theta, and tangent theta times a -1 is a negative tangent theta. 2 tangent theta minus tangent theta is a positive tangent theta. So these are equal. And so therefore these are my factors. 2 tangent theta minus 1 and tangent theta plus 1. So basically I've just taken this and factored it. Now if I were to FOIL this, I should get back what I start. And if you don't believe me that it's true, try it and you'll see that it is. Now, since I've got the 0 product property right here, because I have the product of 2 things that are equal to 0. So this whole equation is true when 2 tangent theta minus 1 is equal to 0, or when tangent theta plus 1 is equal to 0. Because remember the 0 product property, when either of these are equal to 0, the whole side is equal to 0. And we're basically concerned at when this is equal to 0, because, well, that's what it says in the beginning. When is all of this equal to 0? And so now I solve this. Add 1 and divide by 2. Tangent of theta is equal to 1 over 2, or tangent of theta is equal to a -1. Now I would say tangent inverse of 1/2 is equal to theta, or tangent inverse of -1 is equal to theta. Now our answers need to be in radians, but what I'm going to do is I'm actually just going to work in degrees, and until the end I'll convert it into radians at the end of the question. That way it'll keep it a little more simple, and I think a lot of people like degrees anyway. Excuse me. So I'm going to do tangent inverse of 0.5. Oops, I didn't do inverse. Tangent inverse of 0.5. It's 26.6 degrees. Tangent inverse of -1 is, oh, I should have known that, -45 degrees. Okay, and so these are my two solutions, here and here. But these two solutions came from the fact that I had the zero product property. Zero product property, if there's two products, then each product can produce a solution. Now, each of these will also produce another solution because they're trigonometric equations. So some of these are actually going to have 4 solutions. How do we find the 2 more solutions? Remember how cosine is symmetrical around the x-axis? Meaning that if the calculator gives me one of these as my angle, then this angle is the other one. And sine is symmetrical around the y-axis, meaning if the calculator gives me one of these as my angle, then this is the other one. Well, tangent is symmetrical around the origin, meaning if the calculator gives me this as my answer, then my second answer is 180 degrees further away. So for tangent, all you have to do is add 180 degrees. 26.6 plus 180. And here, -45 plus 180. Okay? And now I would take all 4 of these answers and multiply them by pi over 180 in order to convert them into radians. Okay? And that's basically the idea. Let's do one more. We'll do a sine one here. 2 sine squared of 2 theta minus 3. This is one of the more complicated ones. Notice I have a 2 theta inside my sine. What I'm going to do in order to uncomplicate this, I'm going to just say, let's get rid of that, and let's say 2 theta is equal to u. Okay? And then what I'll do is I'll come back here later. I'll do this part later, and I'll change my actual equation to sine squared u minus 3. And now what I'm going to do is I'm just going to try and solve for u. And I'm going to find as many answers as I can for u. And then, excuse me, once I find some u, or some u's, I'm going to take those and plug them into here and solve for theta, which, by the way, solving for theta in here would be theta would equal be u divided by 2. So in the end, I'm just going to take all of my solutions and divide them by 2. Okay? And so, let's begin. Let's add 3 to this side, and I'll get a 5. Wait. This doesn't seem like it's going to work out very well. I'm not going to get any solutions to this. As well, what's the square root of 5? It's too big. Hold on, let me change this equation so we actually get some solutions here. Let me change this to a positive 3. And what I'll do is I'll subtract 3. So I'm changing that to a positive 3. And so I'll subtract 3 and 3 from both sides, and I end up with a negative 1. And, oh shoot, I'm not going to end up with a solution here either, because then I'm going to have to take the square root of both sides. Alright, sorry, let me revamp this a little bit here. $1.5. Okay. So if I have 1.5 here, and so if I divide by, or sorry, now if I subtract a 1.5, I'm going to get a 0.5 is equal to sine squared u. Okay, then in order to get rid of the square, I'm going to have to take the square root of both sides, and so I say that the sine of u is equal to plus or minus the square root of 0.5. Okay, and so I'm going to have to figure out, I've got two situations. Case 1. Case 2. I have where the sine of u is equal to a positive square root of 0.5, or where the sine of u is equal to a negative square root of 0.5. And then so we have the sine inverse of the square root of 0.5 is equal to u, or the sine inverse of a negative square root of 0.5 is equal to u. Okay? So remember, I just take the sine inverse of each of these. Then in my calculator, I figure out what that is here. Sine inverse of a negative square root of 0.5. Enter. Is oh, that works out nice. negative 45. That was this one. I didn't realize I was doing it. And then, so let's now look at the other one, which I believe is going to be maybe like negative, positive 45. Okay. So these are our angles here. But remember, since we're doing these are two of the solutions for you right now. Okay? So I'm going to take and I'm going to try and find a couple more solutions for you by drawing this these things here. So if I take 45 degrees, remembering that the sine function is symmetrical around the y-axis, then it looks like this one will also be a solution. And so 45 and then 180 minus 45 will also be a legitimate solution, because this is 45, this is 45. You've got symmetry here. So 180 minus 45 is also a solution. Then I've got negative 45 right here as an angle. And so the other angle is symmetrical around the y-axis because I'm using sine. So the other axis is, or the other angle is actually 180 plus 45 degrees. And so I'll figure out what those are real quick. 180 plus 45 is 225. U can equal 45 as well. Negative 45, by the way, is not in the domain, because remember, we're actually looking for angles between 0 and 360. So I have to figure out 360 minus 45. 360 minus 45. $315. And then let's see, I need also 180 minus 45. $335, 135. I should have known all of those, but it's just making sure here. Okay, so now it turns out, because we have this equation here, there's actually going to be 8 solutions to this. What I'm going to do is I'm going to take all of these and I'm going to write down some more u's. 225 plus 360. 45 plus 360. 315 plus 360. And 135 plus 360. These are actually all also going to give me solutions. Okay, so